Hi everyone, welcome to Byte Ventures, where we deep dive into the marvels of technology. In today's case study, we'll discuss about the event notification system at Netflix, how Netflix handles so much crucial events at such lightning fast speed. Without further ado, let's dive deep in. So the first thing first, so Netflix as a streaming company which helps us watch our favorite movies or web series or TV series, why would it care about an event notification system, right? But not really. So Netflix claims to have more than 200 million active user base. That means any user will have multiple devices connected. That means when they will generate any action on one device, that needs to be propagated to all of the other devices, right? There'll be various other user generated activities as well as system generated activities that needs to be transferred from one place to another. And that's why they need to have a notification platform built in. In certain cases, we need to troubleshoot various use cases as Netflix. So Netflix will be firing some signals so that it maintains the health of the services that are communicating between each other. And that they do for providing a seamless and better experience every such day. And that is why they need to handle the troubleshooting use case as well. The most important thing in all of this is propagating this all events as soon as possible to the required device, because this eventually will improve the user experience the customers face, right? That is very important. And this is why Netflix is building or has built its in-house notification system, which they named it as Reno. So Reno is rapid event notification system, which they have built in-house to support all of the use case where they need to transfer events from one source to another, be it for a user or be it for a platform specific thing where they need to transfer some events as part of Netflix to all of the connected devices. Without further ado, let's see how Reno is built, what are the requirements it supports, and how all of the things are stitched together by the end of this. First things, what are the source of events? We discussed there will be various source of events because there are a lot of devices connected. Each will have multiple devices. Let's just dive deep in. So the first thing is when there are multiple devices connected for a single person, it is very important to translate the viewing activity. That means whenever I'm watching something new, it should update all of the connected devices with continue watching list to provide a seamless experience. For example, I started to watch a new series, for example, series A in my laptop, and I just turned off my laptop because it went out of charge, and I continued to browse Netflix on my app in my iPhone, right? So to provide a seamless experience, it is very important that they provide that, okay, you have watched the first 10 minutes, you should continue from 11th minute from this. That is very important for me to not start from the beginning, which will be a very big pain, right? And if you are coming from an ML or data science background, then you must know that Netflix has one of the very highly known recommendation system. That means whenever I'm watching something new, the new data needs to be fed into the system, and the platform as a use case should update my recommendation list across all of the platforms that I have. Second thing is the membership plan changes. When a membership or when a member changes its plan from a free tier to a premium tier, it should upgrade or degrade depending on the requirement, all of the shows and all of the movies accordingly. My list. So if you have seen Netflix as a platform, you can see that you can add certain things into your list where you can watch it later or something that intrigues you, right? That means if I add something on one device, it has to have updated across other devices as well. So this is a critical source of events. The next is member profile changes. So if you have thought about using Netflix or have been using Netflix, so there is a way to create a different profiles, right? So I, as the owner of a Netflix account, can create 4 or 5 profiles depending on the type of plan I'm subscribed to. And I can change the maturity levels based on whether it is a kid account, whether it is an adult account, and all stuff. It's very important to handle those events and propagate them as soon as possible to the required devices as efficiently and as seamlessly as possible. Last but not the least is the system diagnostic signals that we're talking about. In many cases, Netflix as a platform raises many signals to make sure that the devices that are connected are efficient, right? So they want the system diagnostic signals in such cases would help them achieve the optimum performance from each device. Okay, now that we know that these are the sources of the events, let's talk about what this platform would support. What are the rough requirements that we have so that this platform would need to eventually? The first thing and the obvious use case is the high scale. With more than 200 million active users, each user will have 4 to 5 connect devices at the least. A laptop, a phone, a smart TV, and stuff like that. So we need to optimize the performance so that we don't give out a lot on the efficiency because we have a high scale. So that's why there is a high need for optimization. Let's talk about what are the optimization strategies that we need to take into account while building the system. So first thing is aging. So if you think about it, it's pretty obvious that there are certain events which are very time sensitive. That means they need to be delivered at the right time to make much sense out of it. If they cross certain threshold, then it doesn't matter if they're delivered or not because the value they were provided to add is gone now. That's why we need to have an aging gate that would help us weed out the unnecessary events in case of high scale system. The second is notifications to filter devices. That means to reduce the footprint of delivering notifications, it is important to deliver the notification only to the connected devices for now. The third and the obvious use case is the thundering herd problem. So whenever such a huge scale of system come in, the thundering herd problem says that it can happen that a particular point of time sees a high spike. This high spike requires access to the critical resource, and in turn, that degrades the whole performance of the system. That means the system should be elastic and scale enough to handle the incoming load pretty efficiently. The fourth is event duplication. That means in such a high scale system, it's pretty obvious that there will be duplicated events, but we cannot send out duplicated events in this case. So the platform or the service that we're building should have the capability of event deduplication as a first class citizen. And the last but not the least, that we'll be using very downstream services like Firebase Cloud Messaging System, FCM, or Apple's push notification service to deliver the events in the last mile to the actual devices. So the failure of the downstream services should not be a blocker for the whole system to go down. So it should be very resilient in that case as well. Okay, let's move on to the second requirement. The second requirement is a single source event. That means it would be very easy and hassle-free to have a single source of all of the events, though there'll be various places from which events are getting generated. But if they are brought together to a single place and they're fired from that place, it would be very efficient for us to manage, debug, trace, observe, and everything. Third is event priority. You must have guessed by now, right? For example, if I have two events, for example, my recommendations updation event and updation of maturity level in a new profile, which is important. Of course, updation of maturity level in a new profile is very important. The fourth is the communication model. So we know that events are getting generated from the source, but the main issue is that we need to have a communication model so that that reaches the end device, in this case an iOS or Android or a TV in this case. But if you think about it, we cannot only rely on a push-based communication or a pull-based mechanism, because for devices that are not connected to the internet, it is wise to implement a pull-based or pulling mechanism. And for devices that are connected to internet, it is very important that we don't make the app chatty. So that's why we need to have a push-based mechanism for that cases. And last but not the least, the platform should support direct delivery in such cases that an event is notified for a particular device out of 5 or 10 devices. This service should give me the capability to do that. That means we have high scale or the support for high scale, It should have a single event source. It should have event priority. It should support hybrid communication model, which is actually a push and a pull based model. And it should give me a capability to deliver to a particular device that I want to target to. Okay, now that we know the requirements, let's talk about the architecture. What would be the architecture looking like in this case? What would be the architecture in such cases to satisfy the requirement that we need for us to support, right? Okay, first things, the source of events, where they're getting. There'll be multiple places, but as we have discussed, that they need to be synced into a single place so that we can fire the events from a single place. That's why these are the event triggers that we talked about. The member title watch activity, personalized suggestion refresh, my list updates, system diagnostic signals, and etc. So these are the event triggers that we're talking about. These get fed into an event management engine. So Netflix has built a very efficient near real-time event flow management system called Manhattan. This is called Manhattan, which they have internally developed, and they will leverage this facility to manage the event flow from a single place. So now that we talked about priority, right? So there should be some kind of priority for us to manage the event. So each event should not be of a default priority, but rather have a priority based on the criticality or the urgency of the event to be delivered. So we use something called as Amazon's SQS, or the simple queue service. So each one of them is a queue where they manage each event in a different priority. That means this handles priority as 1, this probably handles a priority of 2, this handles a priority of 3, a priority of 4, and a priority of 5. Let's say we have events priority ranging from 1 to 5. There are 5 different queues to handle that. Of course, there will be redundancy where this queue is replicated in all stuff, but on a simple use case, this would be the case, right? So Netflix is using Amazon SQS as their architecture to handle the priority of the events. So now that we have priority established, there needs to be specific clusters to handle different priorities very efficiently. So they use the Amazon instance clusters in this case. These all are the instance clusters that we have, which eventually handles each of the queue independently. That means each cluster is responsible for handling a certain kind of priority based on its configuration. So now that we have event source getting generated, we have the event management engine here. We have implemented SQS so that it handles the events based on the priority, and we have assigned specific compute clusters to compute them. So it can happen that they are just messages. There's some kind of processing required, and these instance clusters will be responsible for all kind of processing, generating the template, enriching the messages, massaging the events to make sure that it is intended to do what it wants to do. Now the delivery part. So once this processing is done, Netflix wants to deliver these events to the end devices. So there are two kinds of interactions here. That means we discussed that there should be a push-based model and a pull-based model, right? That means the devices that are now connected to the internet should go with the push-based model first. So let's say the Android phone and the iOS are the devices which are kind of connected always to the internet. This is the assumption we're taking. And that's why they need to be delivered these events as soon as possible. So Netflix employs this outbound messaging system, which is also in-house developed. So it is their in-house message orchestration service. So they use that to deliver the last mile events to these devices. And this is the external service. So FCM is Firebase cloud messaging system. APNS is Apple's push notification service. So this messaging orchestration service that Netflix have built internally leverages external systems like FCM and APNS to deliver these notifications to the end devices. And also to keep track of all of the events, it stores all of the Reno events in a Cassandra database. So Cassandra is a highly scalable NoSQL database, which can process huge scale. Interesting. So now we have talked about one such case where we discussed that, okay, this is push-based thing where we push the events to the devices that are connected. Now, what about the devices that are not connected the internet all the time. For example, my web app or my smart TV. You're exactly right. Now we need to have the hybrid communication model kicked in. That means they need to have a pool or a pull based model wherein the web apps in this case and the TV apps would pull the database in this case to identify what all events are targeted for them, get those events, apply and make the necessary changes in their respective system. But there is a very important concept which is called Zul push. Zul push, but kind of a push based mechanism that they have. So Zul is internally another service which is a cloud gateway that they've built. So Zul 2 is something very interesting. We'll cover it in one of the future videos where it can help Netflix maintain a persistent connection to the devices at the scale that they're handling, like 200 million users. So this is the overall system. The top has the event triggers. This triggers the events into the event management engine, which is the Manhattans. And then they have this event priority based queues, which is Amazon's SQS, which they have it right here, where each event or each event having a different priority is processed differently. And similarly, it is taken further where each of the cluster processes each event differently. And then a push and pull based mechanism implemented using third-party libraries and third-party services as well as Cassandra cluster. Okay, so what are the very specific wins that Netflix get? So Netflix has the use case agnostic support. That means it can easily onboard any new kind of events with its rapid event notification service. And secondly, scalability was something Netflix thought about from the beginning. That's why it scales pretty efficiently, even if without higher throughput, without any delays or any lags. So it is very efficient because the scale up policies are very aggressive in comparison to scale down policies. And that's why it can happen that whenever there is a spike, you won't see a difference because Netflix has thought about that right before. All right, that's all for today. I hope you liked the video. And if you have learned something new, don't forget to like the video and subscribe the channel for many such insightful videos. If you have any questions or feedbacks, please let me know in the comment section. Otherwise, I will see you in the next one. Thank you.